Hey everyone, welcome back to the deep dive. Today we're diving into unit testing in Java, specifically effective unit testing by Lasse Koskela. You can think of it as our own personal coding dojo. We'll be sparring with excerpts from the book, the preface, and a ton of practical tips to level up your testing game.
Yeah, and what makes this book so interesting is that it started as a translation of a .NET book, but the author quickly realized that, Java's got its own quirks.
Yeah, like trying to fit a square peg in a round hole. So our mission today is to find those golden nuggets, those Java-specific tips, and figure out how to apply that to, our own projects. We're talking about writing tests that are clear, maintainable, and even enjoyable to write.
Absolutely. And to get into that, we'll explore what makes a good unit test, what makes a bad unit test, and of course, how to avoid those test smells.
Ooh, test smell. That sounds intriguing. But before we get into good tests versus bad tests, let's talk about why unit tests are so important in the first place. The book opens with a story about Marcus, a young programmer who kind of sees testing as a chore.
Yeah, he's like a lot of us starting out focused on just getting the code to work. He thinks of tests as something you tack on at the end. But then he meets Sebastian, this seasoned architect who embodies the whole test first thing.
Sebastian, the coding sensei.
Exactly. He lives and breathes test-driven development, TDD, starts with a failing test, writes just enough to make it pass, and then refactors, refactors, refactors.
The classic TDD cycle. Red, green, refactor.
Precisely. And here's where it gets interesting. Working with Sebastian, Marcus discovers that this whole write test first thing, it actually leads to better design. It makes him think about the code from the user's perspective
Oh.
to, anticipate how it'll be used. The result is code that is more modular and less complex.
So it's not just about catching bugs, it's about using tests to guide the design.
Absolutely. And this leads to something Lasse emphasizes in the book, shifting our focus from tests to behavior. This is the heart of behavior-driven development, or BDD. Instead of, how do I test this? It's, how should this behave? It's subtle, but it's powerful.
Right? At the end of the day, users don't care how many tests we write. They care about how the software behaves, if it's reliable and easy to use.
Precisely. By focusing on behavior, we naturally take a more user-centric approach, and that makes all the difference.
Okay, so we know unit tests can guide design and ensure correctness. But we've all seen those less than ideal tests. Tests that are confusing, brittle, painful to work with. What makes a good test? What are the qualities we should be looking for?
Well, the book dives deep into that. It stresses that a good test, just like good code, should be readable. You should be able to look at a test and immediately know what it's doing without having to decipher anything.
Because if a test is hard to understand, it'll be hard to maintain. And we definitely don't want our test suite to be a burden.
Exactly. Maintainability is key. Your code base will evolve, and your tests should be able to adapt without major surgery.
Right, because if every code change breaks a bunch of tests, you'll spend more time fixing tests than actually writing new features.
Absolutely. And finally, a good test needs to be reliable. It should consistently give the same result. None of those flaky tests that sometimes pass and sometimes fail for no reason.
Flaky tests, the bane of my existence. They're like that car alarm that keeps going off for no reason.
A perfect analogy. They erode trust in your test suite and make it hard to know what the real problems are.
Right, you never know if it's an actual bug or just the testing environment. So readability, maintainability, reliability. Those are the three pillars of good unit tests. But these can be challenging when you're dealing with things like time, randomness, concurrency, or external dependencies, like databases, network calls, third-party libraries, all those things that can mess up our tests.
Absolutely. These are the areas where unit testing gets tricky. But the book offers some advice. For instance, if your code uses a database, you can use an in-memory database for testing. This makes the setup simpler, your tests run faster, and it avoids having to set up a real database for each test.
That makes sense, finding those pragmatic solutions without adding extra complexity.
Exactly. And if you're dealing with threading or concurrency, the book recommends splitting your code into asynchronous and synchronous halves. This way, you can test the logic in a simpler, synchronous environment and isolate the concurrency aspects for targeted tests.
Right, because testing concurrent code can be a real headache. So break down the problem, isolate the complexity, and choose the right strategy for each piece.
Exactly. And speaking of breaking things down, let's talk about test doubles.
Test doubles, like stunt doubles for our code.
Laughter. In a way, yeah. Test doubles, like stubs, fakes, spies, and mocks, they're stand-ins for real collaborators in your code. They let you isolate the code you're testing and control its interactions.
So instead of testing like a huge interaction between a bunch of things, I can use a test double to simulate one part and focus on just the code I want.
Exactly. And this isolation has several benefits. First, it gives you control over dependencies. You can simulate certain scenarios and responses, making your tests more predictable.
Like a controlled experiment.
Exactly. Second, test doubles make tests faster. Instead of hitting a real database, which can be slow, you use a double with a pre-canned response. Tests run faster, feedback's quicker.
And I'm all about speed, especially when it comes to feedback.
There's more. Test doubles make execution deterministic, removing randomness. And they let you simulate those rare edge cases that are hard to reproduce.
It's like having superpowers in our tests.
You could say that. Now, the book has a helpful way to remember which type of double to use. Stub queries, mock actions.
Okay, so stubs are for data and responses, and mocks are for verifying interactions.
You got it. And for structuring your tests, the book recommends a range act assert. You arrange your objects, then trigger the action, and finally, you make your assertions.
Like setting the stage, letting the actors perform, and then judging the show.
Precisely. So we've covered a lot, but the book doesn't stop there. It goes into a catalog of test smells, pitfalls that can make your tests hard to work with.
Ooh, test smells. I'm guessing these are things we want to avoid.
Absolutely. They're warnings that something might be wrong with your tests, and that's what we'll dive into next.
Okay, let's talk test smells. What are these things we should be avoiding?
Well, first we've got hyperassertion.
That sounds kind of intense.
Imagine you're testing a simple logging function. Instead of just checking that the message has the right info, it checks everything. The exact timestamp, log level, thread ID, all of it.
So it becomes really brittle, right? Any tiny change could break the test, even if the core functionality is fine.
Exactly. And it also makes it hard to see what the test is really supposed to be doing.
So how do we avoid this?
Focus on the essential behavior you're testing. What's the minimum you need to verify? In the logging example, maybe just check for the error code. That's it.
Don't sweat the small stuff. What about split logic? What's that all about?
That's when one test tries to do too many things. Like, imagine a test that's verifying both creating and deleting a user account.
Trying to do two things at once. It's going to be hard to understand and maintain.
Exactly. If it fails, you don't know which part broke.
The solution is simple. Split it up. One test for creating, one for deleting.
Right.
Okay, what about slow tests? We've all seen those tests that take forever to run.
The book calls those sleeping snails. Often, the culprit is thread.sleep.
Oh yeah, I've used that before. Especially when waiting for something to happen.
It's tempting, but it's not ideal. You're just guessing how long to wait. If you guess wrong, the test is either too slow or it could start failing randomly.
Because the actual time can change depending on so many factors. So what's the alternative?
Synchronization. Instead of blindly waiting, use things like semaphores or callbacks to signal when an operation is done. That way, you wait the exact right amount of time.
No more guessing games.
What?
Okay, what else is there?
Let's talk about pixel perfection. This one often comes up in UI testing. It's the tendency to test every single pixel, making tests incredibly fragile.
Pixel perfection. So if the UI changes even slightly, the tests break, even if it's still working correctly.
Exactly. You're not actually interested in the exact pixels. You want to know if the UI elements are in the right place and have the right size.
Right, we want to test the behavior, not the exact visual details.
Exactly. Instead of pixel comparisons, use assertions that focus on, like, the coordinates or size of the elements.
What else is there?
Let's talk about the parameterized mess. Parameterized tests are great, but you can go overboard with them.
I love parameterized tests. They're so useful for testing different inputs.
Yes, but if you have too many data sets, it becomes hard to manage.
Like an overstuffed suitcase, you can't find anything.
Exactly. It hides the purpose of the tests.
So how do we keep them organized?
Use them strategically. Small, focused data sets, meaningful names, and maybe group-related tests into separate classes.
Okay, that makes sense. Now let's talk about something that's not really about code. Misleading comments.
We've all been there. A comment that seems helpful but is actually outdated or just plain wrong.
It's so frustrating. You think you understand what's going on, but then you spend hours debugging and realize the comment was lying to you.
The best way to avoid misleading comments is to write self-documenting code.
What's that?
Code that's clear and easy to understand on its own. Use descriptive names, break down complex logic, and write good tests. If the code is clear, you need fewer comments.
So the code speaks for itself. Makes sense. What else is there?
Let's talk about platform prejudice. This is when tests make assumptions about the operating system.
So our tests might be biased.
In a way, yes. Imagine a test that uses Windows-style file paths. It'll break on a Unix system.
Right, those file path differences can be tricky.
And the problem is, your tests might pass on your machine but fail somewhere else.
So how do we avoid this?
Abstract away those platform-specific things. Use tools and libraries that work across platforms, and don't hard-code things like file paths.
Makes our tests more portable. What's the last test smell?
Let's wrap up with conditional test logic. This is when you use if-else statements or other logic inside your tests.
It seems efficient, testing different things with one test.
But it can make tests harder to understand and potentially hide failures.
How so?
Imagine a test that checks for an exception, but only if a certain condition is met. If the condition is wrong, the test might pass even though it should fail.
That's a sneaky one. So what's the solution?
Keep it simple. If you need to test different things, write separate tests.
Each with its own clear purpose.
Exactly.
Okay, we've talked about what not to do. Now let's talk about how to write good tests from the start. How can we make our Java code testable?
Well, the book says testability is a design principle. It's not an afterthought. Remember the solid principles.
Yes.
Those are really helpful for testability.
Remind me which ones are most important for testing.
The dependency inversion principle is key. It says our code should depend on abstractions, not specific implementations. Like, instead of depending on a specific database, depend on a database interface. Then you can easily swap in a mock database for testing.
Like an adapter that can connect to different things.
Exactly. And the interface segregation principle goes with that. Smaller, more focused interfaces. You only mock what you need, not everything.
Less mocking, less complexity. What other design tips does the book have?
It really likes composition over inheritance. Inheritance can make things tightly coupled, hard to test. Composition lets you build from smaller, testable parts.
Speaking of building, what about the new keyword?
Yes. Every time you use new, you create a concrete dependency. Try to inject dependencies instead through constructors or setters. That gives you more control and makes mocking easier.
So less new. Interfaces, composition,
Hmm?
anything else to watch out for?
Singletons and static methods can be tough to test. They hide dependencies and have global reach.
Yeah, those can be tricky.
Again, dependency injection helps.
Okay, what about external libraries?
Wrap them. Create a wrapper class with a simpler interface. This makes it easier to test and protects you from changes in the library.
So wrapping gives us more control and makes mocking easier.
Exactly.
What about tooling? Any tools or frameworks that can help?
The book mentions some interesting ones. Have you tried Groovy or Scala?
I've heard they're less verbose than Java.
Right, they can make writing tests much faster and more enjoyable. And for behavior-driven development, check out EasyBub and Spock. They're all about clear, readable tests that focus on behavior.
Cool. I'll have to look into those. Now, what about build times, especially on big projects?
The book covers that too. It talks about profiling and optimizing build times with things like Maven profiles. And it even goes into parallelizing and distributing builds, which can really speed things up for large projects.
Wow, we've covered a lot.
We have. And as we wrap up this deep dive into effective unit testing, I think the most important thing is to remember that it's about continuous improvement, always striving to write better tests that lead to better software.
Well said. Any final thoughts for our listeners?
Remember, we've focused a lot on the technical stuff, but the real power of unit testing comes from shifting our mindset. Think about behavior, not just code coverage. Use tests to drive design and build confidence in your code.
That's a great point. It's not just about writing tests, it's about using them to write better software. So to all our listeners out there, go write some awesome tests. Keep learning, keep experimenting, and until next time, happy coding.